But the first kind of factoring we're going to do is with trinomials. If this says it's a trinomial, how many terms are there going to be in a trinomial? 3, right? That's what tri means, is 3. So when there's 3 terms, specifically of this form here, ax squared plus bx plus c, so a quadratic, you've got a number a in front of the x squared, a number b in front of the x, and a number c in front of that. That's going to be a trinomial, right? And today we're only going to tackle trinomials when a is equal to 1. So when the leading coefficient, the number in front of the x squared, is just 1. So if you look at all 5 of these problems, these are all trinomials. They're all 3 terms. They have an x squared, an x, and a number, right? So they're all trinomials. They have 3 terms. They're this form, x squared, x, and number. And there's no number in front of the x squared. So a is 1 for all of these. These are really easy to factor. Tomorrow we'll tackle what happens with the a is not 1, okay? And that's a little bit, it's probably the most complicated one, what we have to do when a is not 1. But when a is 1, they're really easy, okay? All you're going to do is you're going to look for 2 numbers that multiply together to get c, so the number at the end by itself, but also add together to get b, the number that's in front of the x term. So when I go to factor this, remember factoring is undoing multiplication. So this is going to factor into 2 parentheses just like our grouping did, okay? And remember when we do multiplication, right, we distribute. And the first thing we always do is these 2 times each other, right? So whenever you have just an x squared in the front, these 2 are really easy. What are these 2 things going to have to be if we multiply those together and we get x squared? They're just both going to have to be x, right? So when you have just an x squared in the front, it's really easy what the start of your factors is. It's just x, because if you were to go back and check this and distribute, the first thing you would do is x times x, and you would get x squared, right? So then all we have to do is figure out what these 2 numbers are for your factors, and that's why we're going to look for this. We're going to look for 2 numbers that multiply together to get c and add together to get b. So for this problem here, we're going to look for 2 numbers that multiply together to get what? What's our c for problem number 1? 8. And we're going to look for 2 numbers that add together to get the middle term number. So for this one, that's 6. Now, you may have done an X method or a star method in another class, like where you put the number in the top and the bottom. You're welcome to do that if you like that. I just always forget which one goes where because I never learned it. So you're welcome to use that if you like it. We're doing the same process. It's just a matter of a different organization, okay? So I like to start with looking for the numbers that multiply together to get 8. So what's an example of 2 numbers that multiply together to get 8? 4 and 2. What other 2 numbers multiply together to get 8? 1 and 8. Now, only one of them is also going to add together to get 6. Which one of those combos is also going to add together to get 6? 4 and 2, right? So we don't want 1 and 8. Those will add together to be 9, right? So our numbers are 4 and 2. So what we just did is we figured out what these parts of our factors have to be. That's going to be x plus 4 and x plus 2. Because those 2 numbers that multiply together to get 8 and add together to get 6 are 4 and 2. Hopefully it rings a bell a little bit, looking for those numbers. You could always check yourself if you wanted to. If you distribute, you're going to do x times x, you'll get x squared. 4 times 2 is 8. And then in the middle, you'll get 4x and 2x, and those will add together to be 6x. Okay, so you could always check your answer if you want to distribute and see if you got it correct. So now let's look at number 2. So for number 2, we know we're going to start with a set of parentheses because it's a trinomial. A is 1 here. So we know these are going to start with just x and x because x times x will give me x squared. So now we just need to figure out what these 2 numbers are. So we're going to look for 2 numbers that multiply together to get negative 18, the number at the end. The sign does matter, so put the negative with it, and add together to get 3, the number in front of the x term. So I like to start with numbers that multiply together to get 18. So what numbers multiply together to get 18? 3 and 6. What else? 2 and 9 also multiply together to get 18, right? Technically 1 and 18 also multiply together to get 18. So these are all your possible combos here. But if we're multiplying together to get a negative 18, what does that mean about one of your numbers if you're multiplying two numbers together and you get a negative? Just one has to be negative. So one's positive and one's negative. If I make the 2 negative here and add these together, I'm going to get 7. That's not going to help. If I make the 1 negative here and add those together, I'm going to get 17. That's not going to help. But which one, if I make it negative here, will I add together to get 3? If I make the 3 negative, right, then if I put those together, they will multiply together to get negative 18, and they will add together to get 3, right? That's what we're looking for. Two numbers that multiply together to get 18, negative 18, and add together to get positive 3. You don't want to make this 6 negative, because those would add together to get negative 3, right? So the signs do matter. So here we will have minus 3 and plus 6 are our two numbers to complete our factors. A lot of you are really good with mental math, and you might be able to even do this in your head most of the time, unless it's a more complicated number, and that's fine. If you're not good at mental math, calculator will be your best friend with this stuff, and the more you practice it, the more you'll recognize some of the numbers. All right, let's do one more together here, because this one has a little bit of an interesting. So you know this is going to factor into x and x, because we have to multiply together to be x squared, and a is just 1. We're looking for two numbers that multiply together to get 20. And add together to get negative 9. So multiply together to get the last number, add together to get the negative number. Okay? What numbers multiply together to get 20? What combos can we do for 20? 4 and 5. What else? 2 and 10. 1 and 20. This one's interesting, though, because our numbers need to multiply together to get a positive, but add together to be a negative. They'll both be negative. Yes. The only way to multiply together and be a positive is they're both positive or they're both negative, right? So if the number that you're multiplying together is to be positive, you have two options. Both numbers are negative or both are positive. But if we've got negatives here from adding, they both have to be negative, okay? So we know that both numbers have to be negative. So if I put negatives with my 2 and 10, that's going to be negative 12. That's not going to help us. If I put negatives with my 1 and my 20, that's going to be negative 21. That's not going to help us. But if 4 and 5 are both negative, and I add those together, will I get negative 9? Yes. So those are your numbers, minus 4 and minus 5. So your factoring will be x minus 4, x minus 5. I want you to try 4 and 5 on your own. So for number 4, we know it's going to be 2 parentheses, and they're both going to start with an x because there's a 1 in front of x squared. So x times x is going to be x squared. To find the other two numbers, we're going to find two numbers that multiply together to get negative 72 and add together to get negative 6. 72 is a tough one because there's a lot of numbers that multiply together to get 72. So you may just have to start going over your calculator. 72 divided by 2, 72 divided by 3, 72 divided by 4, okay? Because we've got 9 and 8 multiply together to get 72, 2 and 36 multiply together to get 72, 3 and 24, 6 and 12, and technically 72 and 1 also, but I don't think that's going to help us get 6, 72 and 1. So we'll just leave it to those 4. Now, we're multiplying together to get a negative. So if we're multiplying together to get a negative, how many of those numbers are going to be negative? Just 1, right? Multiplying together to get a negative 1 is going to be negative. So if I make 9 or 8 negative, that's not going to get negative 6, so that's not helpful. So which one will give me a negative 6 if I make one of the numbers negative? 6 and 12, right? And which one has to be negative, the 6 or the 12? We want a negative 6, right? So the 12 is going to have to be negative. If you make the 6 negative, you're going to get a positive 6, but we want a negative 6. So it's 6 and negative 12. So it's going to be x plus 6, x minus 12. For number 5, you're looking for two numbers that multiply together to get 5 and add together to get 7. There's only two numbers that multiply together to get 5. What are the only two numbers that multiply together in 5? And don't say 2 and 3. 5 and 1. 2 times 3 is not 5. It's 6. But a lot of people do that in this section. So 2 times 3 is 6, not 5. So, but 5 times 1 is 6. But is there any way for me to add 5 and 1 together to get 7? No. So can I factor this one? No. So sometimes it's not possible. And if it's not possible, those are called prime. Remember, a prime number is something that only has factors that are itself and 1. So a equation is prime if you can't factor it. Okay, so if it's not factorable, we call it prime. All right, now these are really easy. These next ones, difference of two squares. A difference of two squares is called a dots or difference of two squares. It's a difference. What does a difference mean? It means subtraction, okay, of 2, meaning you only have 2 terms, and they have to be perfect squares, okay? So only 2 terms and perfect squares. Difference of 2 squares. So if you look at this problem right here, we're going to cross out number 8. We're not going to do number 8, okay? But look at number 6. Is this a difference? Is this a subtraction problem? Is there a minus sign here? Yes, so that's a difference. Are these both perfect squares? Is 16 a perfect square? 4 times 4 is 16, right? And x is being squared, so it's a perfect square, right? So this is a difference of 2 squares. Is this also a difference of 2 squares? Difference. 2 terms. Is 25 a perfect square? Is 9 a perfect square? And x is being squared, okay? So when you do a difference of 2 squares, it's really easy to factor. There are 2 ways you can think about it. You can think about it the same way we just did. We know this, because this one just has x and x, those are just going to be x and x, because that's x squared. You can think about what 2 numbers multiply together to get negative 16, but now, is there a middle term here? Is there a number in front of the x? No, so they would have to add together to get 0. So if you want to use the same method we did before, you would multiply together to get 16 and add together to get 0. Or you can just take the square root of 16. What's the square root of 16? 4. So this will be plus 4 minus 4. Because 4 times negative 4 will be negative 16, and then that will add together to get 0. So they'll cancel in the middle. This one here, it doesn't have just an x there, so you will have an x and an x here. But you're also going to have to deal with the 9. So you can either ask yourself what times what gives you 9x squared, or you can do the square root of 9. What's the square root of 9? 3. So this will be 3x and 3x, plus and minus. It's always plus and minus. And then to find the second number, you're going to do the square root of 25. What's the square root of 25? 5. So you got plus 5 and minus 5. So difference of 2 squares are really easy because they're the exact same, except one is plus and one is minus, because the middle terms cancel out.